So when people are from different country, it is easy to categorize, classify them. Okay, this is Asian. So this is the privilege level. You have different countries with different privilege level for different continent people. I tell you, go to Middle East and for a job. If you're coming from Asia, this is your salary. For the same role, if you're coming from US, there's another salary. If you're coming from Europe, there is another salary. So this country, continent, divisions help to classify, group people. So that if they want to deny some country, they easily deny. If they want to give special privilege to country, they easily can apply that special privilege to the group because they're already identified as a group. Passport color, passport name, Republic of blah blah. You know, so this divisions help to classify, and it helps to filter or permit, deny or permit. Likewise, in OSPF also you have various group classifications. Like passport, Indian passport, Singapore passport. When you take that passport, they know you are from Singapore, you are from India. Likewise, when an advertisement comes, it knows from where this advertisement is coming to, which area this belong to, is this allowed here, can we deny this or permit this. So if I want to deny other area networks, it is easy because it is already classified. Local area advertisements will look like this. Outside area advertisement will look like this. Advertisement coming from ABR will look like this. Advertisement coming from ASBR will look like this. Like you have names for different country passport. The advertisement coming from different region of OSPF autonomous system also got different color, different name, different ID. So if I want to deny all those advertisement coming from an ASBR, for me it is easy because it is already colored, it is already marked that these advertisement means, if it is LSA type 5 means it is coming from ASBR. It is already predefined, known. LSA type 5, I need to just match LSA type 5, deny, because I don't want any advertisement coming from ASBR. So ASBR is a type of router where we do redistribution from some other protocol into OSPF. So if you want to deny the routes coming from other protocol into OSPF, all that you need to do is, no need to write an access list matching those external networks. All that you need to do is match the LSA type 5, deny. So when you have different advertisements, you can easily filter or permit or provide some special service for a specific group. ABR is one group of router. In each area you will have one or two ABR that is having a special type called type 3. So when I deny all type 3 LSAs, which means I'm denying all the traffic coming from other areas ABR. So link set advertisement in OSPF helps us to identify from where these advertisements are coming. If we don't have different type of LSAs, if we don't have different type of LSAs, when we don't have different type of LSAs, you will not be able to classify, differentiate, group all advertisement coming from area 1, area 2, area 3, area 0, all will look same, and you will not be able to filter traffic coming from one particular area. When it is allowed to give different privilege level, different levels of privileges for human being, it is okay to give different levels of priority in the network. OSPF does that, helps to do that with the help of LSA types. Now let us see one by one the LSA types that we got. Type 1 LSA is called as router LSA. The name of the LSA itself is a router LSA. Type 2 is called as net LSA. Type 3 is called as summary LSA. Type 4 is called as, again, another summary, but this is ABR, or you can say area border summary, or it is generated from ABR, but it is the router ID of ASBR. So you can say type 4 summary, autonomous system, ASBR summary. There's a big difference between this and this. We'll discuss about this shortly. But both are called as summary LSA. Type 5 is called as external. External autonomous system, external LSA. So this is external LSA. Type 5 is external LSA. Actually, this is also something related to ASBR. So you can say AS, autonomous system external LSA. Now there is type 6, 7, 8. Type 6 is when you have multicasting. Type 7 is not so stubby area. Type 8 is when you have OSPF along with BGP with some special concepts, special attributes like community. This may be used. So that's for BGP, you can say. I'll give you the exact name here later. And then 9 is opaque LSA, 9, 10, 11. Now this is like, you can use it for anything. This is used right now for IPv with IPv6. This is used along with segment routing and so on. Some special services, if you want to add, you can use these numbers to advertise those special services. That's what 9 to 11. So as we saw, LSA type 1 is called as router LSA. The reason is this is a LSA that is advertised by every single router in this OSPF domain. This one will not be sent out of the area. This is local within an area. See, this is an advertisement about the networks in that area, but every router advertises the networks that they have, the LSA types, the links to advertisement. But these advertisements are not supposed to, they will not go outside the area. They do not leave the area. So if a router is in area 1, the advertisement of that router, if it is type 1 LSA, it will it will be given to every router in that same area, but not to other area routers. So within an area, this advertisement goes to every router and informs about the network and link status. So this is not the advertisement that provides information to other area. Other area will not know about this area through this LSA, through this advertisement, because this advertisement is not allowed to go out of the area. When we have multiple areas, we got some routers inside. We all know that without backbone, other areas cannot communicate. So we have another area, and there is another router here that is intermediate to both the areas. We call this router as ABR. So the networks that are connected to R1, R2, R3, R4 will be advertised as a link state advertisement type 1, LSA type 1. It will go from here to here. It will go from here to here. It will go from here to here. And this will forward it here and here. But this will not forward it to the next router. It won't forward it to R5. The reason is this link is in area 0, different area. This link via which you received is in area 1. Because this is in area 0, this link is in area 0 R4, and this link is in area 1 R4. R4 is considered as area border router. Router 4 will know about the networks of R1, but router 4 will not give it to R5 via this link, because R5 connected link is in area 0. If this link is also in area 1, it would have given. But because it is in different area, router LSA cannot go out of area. It is only intra area, within the area. Secondly, we have network LSA. You see, to avoid to avoid how loop occurs in layer 3, if there is confusion in route, then loop will occur. See, if you don't know clearly the route to reach somewhere, sometime you may be looping. You started from a tea shop, you end on the same tea shop after 1 hour. You started driving, and you come back to the same place. But you are thinking that you are going to somewhere, but because you don't know. Same way. When the routes are advertised repeatedly, loop will happen. For example, you see, you got a switch. Now this router, blue, advertises a network. If this advertisement goes to everyone, what usually OSPF router will do, you know, whatever they learn, after learning, they forward it to the downstream. So from B, A has learned, C has learned, and D has learned. After A learning it, if A will give a copy to another neighbor, which is C and D, that will become duplicate. C learned already from B about this network B dot B dot B dot B. But now A is also advertising B dot B dot B dot D, B to C and D. Now what C will think that A is the original owner of B dot B dot B dot B. And now C, after learning this, it gives the information again to D. D already learned from B, after that it learned from A, now it is learning the same information from C. Now C thinks that B dot B dot B dot B is with D. So if a packet comes to D, it will forward the packet which is destined to BBB to router C. Router C will forward it to A. A will forward it maybe sometime to D because D might have also advertised. And sometime, you know, it will be keep on looping here. To avoid this duplication of update, which causes loop. Among this 4 router, one router will be elected based on the priority as a designated router. The default priority on the Ethernet link is one we have learned earlier. And let's assume the router ID of this is 2.2.2.2, means sorry, the loopback address. The loopback address of this is 1.1.1.1. This is the address that you have assigned on the loopback interface. Now, when there is a tie in the priority, it compares the router ID. Router ID is the loopback interface address of the router. You can also manually configure router ID. We all know these things. We learned earlier in CCNA level. We can assign router ID manually. If you don't, it picks from the loopback interface. Now the priority is a tie, so router D is becoming designated router. When router D is elected as a designated router, the next biggest will become a backup designated router. We learned this one earlier. And now these two will become DR other router. So what happens? Whenever there is an update, the update will be sent to DR using 224.0.0.6. And DR only will propagate it to others so that duplicate can be avoided. If everyone says everything to everyone, then there is duplication. If everyone will say only to one person, and if one person tells to other, then there is no duplicate, no loop. That's why we have DR-PDR election. So the DR will use 224.0.0.5 to deliver the update to others. So there is a special advertisement going from DR, right? That is what we call it as net LSA. See, net LSA is generated by DR of broadcast or non-broadcast segment, meaning it may be a Ethernet or it may be frame relay on serial. And this advertisement also local to the area. So this is also not the reason for other areas to know about this area. Type 1 and type 2 LSA are only to inform the members of the area about the network. Only the members of the area will know about the network connected to this router. The other area members will never know about my area through these two advertisements, because these two are local to area. The third one is summary LSA, type 3 LSA. This is the reason for other area to know about this area. See, the advertisement type 1, type 2, they are not allowed to go out. Not allowed. Then how area 0 will know about my network? How area 0 will know about the networks of area 1? This type 1 and type 2 is collected here in R4, and our R4 advertises those information to this link, which is in another area, as type 3. So through type 3 advertisement, R5 knows about the networks of R1, R2, R3 and R4. R5 knows about area 1 networks as type 3. And the type 3 did not generate from R1 or R2 or R3. It is generated from R4 only. Type 3 generated from R4. R4 is the EBR router. R4 has got membership with both backbone as well as non-backbone. area border router has got membership with both area 0 and area 1. Only that router can generate this LSA. Type 3 LSA cannot be generated by a inside router. Only a ABR can generate type 3 LSA. Now, why is this LSA called a summary LSA? The name given to this LSA is summary LSA. The reason is, if you are going to summarize the networks of area 1, you will always do this in the ABR because it is the border. Border is the best place to summarize, right? If you want to summarize the networks of area 1, before sending to area 0, you want to send only the summary route. So the best location to do summarization of all these networks inside is this place. And it is the same place where the type 3 LSA also originated. Because the type 3 LSA originates from the summarization point, which is called as ABR. ABR is the summarization point. If you will do summarization for area 1 network, this is the place you can do summarization. We cannot do wherever we want. In EIGRP, you can do wherever you want. But in OSPF, summarization is only in the border. R4 is in the border. So that's the summarization point. And this type 3 originates from that summarization point. That is why they named it as summary LSA. But if you don't really summarize, then just by name it is summary LSA, it is really going to be a detailed LSA. So if you don't summarize, every single network of this area will be advertised. What is the type LSA? Type 3. What is the name? Summary. But is it really summarized? No. If you will do summarization here, then these detailed routes will be advertised as just one single advertisement, one single route. And as the name says, this is truly a summary LSA. Again, I'm telling you, by default, summarization is not done. We have to do it manually. Whether you do summarization or not, the LSAs that is going out from R4 to R5, which takes the network information of area 1, will be called as summary LSA. Let's read what is written here. Generated by ABR to describe the routes of neighbor outside the area. Correct. So it's the inter-area routes, between the areas. The routes of area 1 is given to area 0 as type 3 LSA. So type 3 LSA is generated by ABR. Type 3 LSA got summary LSA as a name because it's a summarization point. Now, there is another LSA which is originating from that same summarization point. That is why they have given us summary LSA as a name. But they don't carry the same information. Listen. Type 3 LSA carries the network information of area 1. Area 1, all the networks are advertised to area 0 as type 3. But type 4 is not like that. Type 4 will come if you have an ASBR. Say for example, this router 2 is connected to EIGRP. Now from EIGRP you are taking the route and redistributing to OSPF. Then R2 will be called as Autonomous System Border Router, ASBR. Now, let us assume the router ID of this R2 is, router ID of the R2 is 2.2.2.2. Now, what happens, if you have an ASBR in an area, the ABR of the router will advertise type 4 LSA saying, I have an ASBR whose router ID is 2.2.2.2. Listen carefully. Router 2 is the router ASBR. Router 2 is the ASBR. But who is advertising to other area that router 2 is ASBR? Who is advertising to other area that router 2 is ASBR? It is not router 2. Router 4 advertises. Router 4 only advertises to router 5 and other routers in all other area saying we have an ASBR and that ASBR's router ID is 22222. See, it is not originating from the real ASBR. It is originating from the ABR of the area where you got ASBR. Understand very well. This is about the ASBR router, which brings the external network. What is external network? The networks other than OSPF. The networks that you learn from some other source like EIGRP. You take it and you redistribute into OSPF. Now OSPF will call those networks as external LS, external advertisement, external network. Now those external networks will originate from R2 itself. R2 itself will advertise external. We call it as type 5. But type 4 is simply saying who is responsible for external. That originates from the ABR. Type 4 is saying we have a router called 2.2.2.2 which is responsible for external network. So for EIGRP, if you are learning 7.7.7.7, that will be carried as type 5. LSA type 5 only will carry that 7.7.7.7 into OSPF, not type 4. So type 4 is actually the router ID of ASBR. So to advertise to other area who is ASBR, type 4 LSA carries the router ID of ASBR and it is generated from the ABR. That is why it is called as summary LSA. All right, if no questions, let's move on to type 5 LSA. Type 5 LSA is called as external LSA. Type 5 is called as external LSA because it brings, you see, it's called external LSA because it brings the networks that are redistributed into OSPF from other source. And this is generated from the router where the redistribution happens. This is generated from the router where the redistribution happens. Right, so we got type 1, 2, 3, 4, and 5. 5 is generated from the ASBR itself. It advertises the redistributed router networks into the area. Those routes, that are redistributed, learning from outside, or in your routing table, if you check, it will look, it will show E1 or E2, E1 or E2. E2 means external type 2, E1 means external type 1. E2 is default, meaning the pathcast is not added. E1 is adding the pathcast. We'll talk about this in detail later, this E1 and E2. I repeat again, the route that are learned via type 5 LSA will be seen as E2 in the routing table. Sometimes it will be seen as E1 if we have changed the type as E1, but the default is E2. As I told earlier, type 6 is for multicast. No Cisco router supported, so I also don't teach this. Okay, so LSA type 6, you don't need to care. LSA type 7 is called as not so stub area. We are going to learn about stub area shortly. We'll see what it is when we go there. See, about type 8 and 9, they have not explained here in this document. As I said earlier, 8 is used when OSPF works with BGP. OSPF, when it works with BGP, you will see. 9, 10, and 11 is called as opaque LSA. OPAQ, spelling is wrong here. Opaque LSA, which is nothing but that can be extended. Those LSAs can be used as an extension for new features. Now it is currently used for various things like I said earlier, IPv6, segment routing, and some sort of extensions. So what we need to do is we need to see this one more time from type 1 to type 7 and understand this with clarity. So let's quickly have a recap. When you have multiple areas, some advertisements are local to the area. Some advertisements are advertised between area. Right, so advertisements that are within area is type 1 and type 2. The advertisement that goes from one area to another area is type 3. And 4 and 5. Repeating again, advertisement 1 and 2, they are not allowed to go out of that area. It's within the area. Advertisement 3, 4, 5 sent out from one area to other area. Type 1 LSA is called as router LSA. It is the LSA, it's a link state advertisement that is sent by every router and it goes to all the routers in that area. Type 2 LSA is network LSA. This originates from the DR only, designated router only, DR only. And this LSA also local to area. So these two LSAs cannot inform other area about the networks that are present in this area. What is that informing other area is a type 3 LSA, which is called summary LSA. Type 3 LSA originates from the ABR. Type 3 LSA originates from the ABR. The name given as summary LSA is because type 3 originating point is an ABR. ABR is the place where if you will do summarization will be done only on ABR. Because this type 3 originates from summarization point, it's called summary LSA. Type 4 is also called a summary LSA because that also originates from the same place. Then what is the difference? The difference between type 3 and type 4 is type 3 advertises area 1 routes to area 0, likewise area 0 routes to area 1, whereas type 4 advertises the router ID of the ASBR. So type 4 LSA will not come from every area. Type 4 LSA will come only from the area where you have ASBR inside. What is ASBR? The router where you take the routes of other source like OSPF, other source like EIGR, PR, BGP, redistribute into OSPF. That redistribution point is what called as ASBR. Type 5 is the one which is carrying the external network. EIGRP routes come inside OSPF as external type 5 LSA. External type 5 LSA originates from the ASBR itself. It originates from the ASBR itself. That we should not forget from where it originates. As I say, type 6 is for multicasting, which is not supported in Cisco. Multicasting is supported in Cisco, but OSPF multicasting is not supported in Cisco. Means that's a special multicast service, OSPF. In Cisco, we have alternatives, so we don't have such. Next, type 7 LSA, we learn when we learn stub types. Most probably in next class we will be having that stub types. But now type 7 LSA is called as not so stubby area LSA. So if you will have an area configured as not so stubby, within that area you will see type 7. Listen. Type 7 will be seen within the area which is configured as not so stubby. This type 7. Next is type 8, which is used along with BGP as external attribute. If there is any need for OSPF to carry BGP information, let me repeat, if there is any need for OSPF to carry BGP's information, BGP is full of what attributes? In that occasion, you will see type 8. Type 9, 10, and 11 is called as opaque LSA, which may be used for various services. Currently, it is used for IPv6, segment routing, and etc. Right. So what we have learned so far is LSA types. What we are going to do next is there are two different types of summarization in OSPF. ABR summarization and ASBR summarization. To learn that, we will build a topology, big topology. We are going to do a lab. We are going to have many areas. There we will learn these LSA types. In the lab environment, we'll see LSA types. I'll show you in the link state database. Show IP OSPF database will show you all the LSA types in each area. After we confirm what we have learned is matching, then we will get into summarization, ABR summarization, ASBR summarization. So this is the agenda for the next session. So we are going to do a lab in which two things we will be seeing. One, the LSA types. Secondly, we learn summarization in OSPF. We got two different type of summarization. Summarization for the networks coming from an area. Secondly, summarization for those networks coming from other autonomous system. In another word, we are going to learn ABR summarization and ASBR summarization. For that, I would like to take I would like to design a topology with 2 or 3 areas. An angle started wire shark instead of genus 3. I'll see if there is any other topology already there ready for our use. We will use it. If not, we need to design one. What do you recommend, Mr. Rahman? Do you want me to use the existing topology, or you want me to do from?
Yeah, go with the existing one. I think it's better. Otherwise, I mean, it's just waste of time. Yeah.
Wonderful.
I think so. I mean,
Wonderful. It's the same
yeah.
thing from my side, but some students like to see from zero level. So, okay, I will use this topology. We're going to use this topology. And I would like to delete this cable between, or I'll keep this link shut down between R4 and R10, means R8. I'll keep this link shut down initially. R8. The device is still not ready, they are booting. So the interface that I'm going to shut down is on R4G3/0. This is down actually. Also on R8G4/0. Okay, so that link is down. It's GNS3, so it is green in color, but it's actually not functioning. This link is down. IP address, OSPF, all configured. And if you see closely, there are some area IDs given, area 50, area 0 in the middle, and area 100 on the right. Now I want to check the routes in the routing table. I'd like to go to router 2 to see what we see there. On router 2, there are two neighbors. And I'm able to see the route coming from local area. In the area 50 routes will be like this. O means this is learned as type 1 or 2. LSA type 1 or 2. The networks that are learned from other area type 3 will be like this. You see router 4 is in another area. This is router 5, which is in area 0. This is type 6, router 6, which is in area 100. So other area routes will have IE, meaning they are learned as type 3 LSA. All those advertisements that are given to you by R3, which is an ABR for this area. R3 is the router which is bringing other area routes. R3 is the summarization point. This one, E1, which is nothing but external type 1. These are the networks that are coming from EIGRP here, you see. 17.6.1 to 17.16.14. You see in the routing table. You got up to 14. Hold on a minute. I am seeing. Okay, this is 172.60. Please don't get confused. Here what you see is 17 is 172. They're not same. And these are the networks that are coming from same area. See, oh. Now, if I'll check the place where the redistribution happens, router 7 is the place where the redistribution happens. Router 7 is what we call as ASBR. And in this router, show run section router OSPF, we are using metric type 1. We'll talk about this metric type in a few minutes. Because it is mentioned as type 1, I see E1. Now, if I'll remove that, I'm going to remove this line completely. And now if you go back and check router 2, these routes should not be seen. 17.6 should not be seen. It is not seen, you see. There is no 17 after 10, it is 172. Now let me do the redistribution without type 1. Redistribute the EIGRP routes include all the subnet and networks. You must mention this command subnet because in today's world we have everywhere subnet and networks advertised. When you don't use the word subnet, then the subnetted network coming as an advertisement will be ignored. Only the classful networks will be advertised. Now E2 is the default. That is what I'm trying to show you. Going back to router 2, now we will see E2 roots. You see E2. Now what is the difference between E1 and E2? E2 is default. What is the difference between E1 and E2? E2 pathcast not calculated. E2 pathcast not calculated, not added. E1 is opposite, pathcast added. For example, when I redistributed, you saw me typing redistribute EIGRP 10. 10 is the autonomous system number of EIGRP. And did I give any metric for those EIGRP routes into OSPF? See, in OSPF, cost is the metric. But I have not mentioned any metric. If I don't mention any metric, the default cost of 20, default OSPF cost for the redistributed network is 20. The 20 is given. So here we don't have connection. Here we have EIGRP down here. Now EIGRP is advertising these networks. These networks. Even the 78. And that route is taken from EIGRP and kept into OSPF. We call it as redistribution. When you do that, cost of 20 is given. Where? In R7. So if you go to R6, you will find cost 20. Let me show you in R6. I'm sorry, here I cannot see because it is N, not stub area, but you see the 20 here. 172.16 is 20. Just pretend that you are seeing E here, not N. Actually, in this area, we have configured not stub area. Let me quickly delete it. I just passed the recording and removed not stub area. If you check now in the routing table of R6, show IP route OSPF, you can see now E2. See, the cost is 20 here in R6. Not only in R6, even on R2, the cost is 20 only. But you see in the topology here, between R6 and R20, there is 1, 2, 3, 4 links available. If cost is 20 here, in router 2, I should have at least 24 as the cost, minimum. If I take 1 as a cost per link, I should say at least 24. But you see, I don't have the 24, I just have the same 20. In R7, it is given as 20, and the 20 is maintained, which means the path cost is not added. Whatever is given during the redistribution period, redistribution place, redistribution time, whatever the number that is given as the metric, it is maintained. For example, I'll go to router 7 and give a number. I'll go to router 7 and say router OSPF redistribute subnet metric. I'm going to say 200. Now in R6 also it will be 200, R1 also it will be 200. That proves that the path cost is not added. Let us go to R6. Earlier it was 20, but now it is 200 because I asked to add cost 200. Even in R2, it is the same. It's the same 200. This is what called as type 2 LSA. Sorry, type 2 external. External type 2 means path cost not added. Now, if I'll make it as type 1, let me go to router 7 and I'll say metric type 1. When I say 1, to the 200 which I am giving as a seed metric, this is what called a seed metric, like a seed I am giving on router 7, and because I said type 1, it will germinate. It will add the path cost, the seed will grow. So if you go to router 6 and check, it will not be 200, it will be at least 201. Earlier it was 200, but now you see it's 300, which means the cost on this link is 100. Now let us go to routers 2 and see it will be more than 300. It's 304. Means after 6, each link has got cost of 1. 301, 302, 303, 304. So you see that it is increased cost. It's not the same cost as you redistributed. It's not the same cost. And you see here it is saying now as type 1 external type. External type 1. Now let us go to R1 and check. Even in R1, if you see show IP route OSPF external type 1 305. Okay, now we need to understand something from this routing table. What is that? All those networks coming from the same area is O. Coming from other area is IA. Same area, what are the advertisement? Type 1 and type 2. Router LSA and network LSA. What is bringing from other area? Type 3. So when you check the database, type 3 should have 4.4 up to 7.7 and then 10.67. Let's go and check that first. Show IP OSPF database. You can see here type 3 is having 4.4 to 7.7 and then these things. These are all coming from other area advertised by router 3. See how clearly it shows. Summary LSA is advertised by router 3. Router 3 is your ABR. From where the other area routes come inside your area. I'm checking this thing in area 50, router 1. And type 1 LSA brings the network information that are inside the same area. And this is the two DR routers. These are the two DR routers, designated routers in this area. In this area, router 1 is one of the designated router. Router 3 is another designated router. And how you know router 1 is a designated router? Because R1 was telling about that. This is the router ID of R1. How do you know router 3 is a DR? This is the address of router 3. Now you can check here, show IP OSPF neighbor. You will see router 2 as a BDR, which means router 1 is a DR. You go to router 2 and check. You will find the show IP OSPF neighbor. You can see that both router 1 and router 3 are DRs. That is the reason why when I check in router 1, the network LSA is coming from router 1's router ID. This is router 1's IP address. And this is router 3's IP address. This is the router ID of router 3. And these are the two networks, these are the three networks that you learn from type 1 LSA 322.333 and 10.16.14.1. So those roots will have O. See 222.333. Nextly, type 3 we have seen. Type 4. Type 4 is the location of ASBR. Now I need to know the router ID of R7. Let us go to router 7 and check show IP OSPF. Here the router ID of OSPF you will find on the top 7777. Now when I go and check on R1 database, show IP OSPF database, you will see 7777 as 7777 as LSA type 4. 4 is also another ASBR, but I have shut down this interface, so I'm not talking about it. But this is also the place where we redistribute. Let me show you. On R4, you will see a redistribute. Look at this redistribution statement. I'm going to delete this. Now you will not see this one. You will not see. Let me show you again. Show IPOSPF database. You see type 4 LSA. Soon this will get removed. We need to wait some time. Let me clear the OSPF process. Go to router 1 and check the database now. This is type 2, this is type 3, and type 4. Okay, it still holds the router 4 as a. We need to wait some time for the latest one. I cleared only on router 4. Router 3's database also need to get aged out. From 7 so far I have received 3 updates, but from 4 I received only 1 update. Because that 7 is, the 4 is no more ASBR. Anyway, so type 4 will only bring the router ID of the ASBR. Who advertises it? It is advertised by the ABR, not by the ASBR. So for this area where router 1 is, the ABR is router 3. Type 5 is the one which is carrying the external networks inside OSPF. These are the networks that we redistributed from EIGRP. Yeah, you see EIGRP runs 78 network and 17.16 network. All right, what next? So we have confirmed these things like LSA types and how it looks in the routing table. There is one command which I would like to show you before I take you to the summarization. Which is this command, Show IP route summary command. This shows how many routes of OSPF we have. 26 subnets in OSPF. Through OSPF we are learning 26 subnets, in which 3 are same area networks, same area. 8 from other area, and 15 is from EIGRP. Type 1, we don't have type 2, we changed type 2 to type 1. So totally 15 plus 8 is 23. 23 plus 3 is 26, that's why you have 26 subnets. Now the space consumed, the memory consumption by this OSPF route is 4078. Now we can reduce this by summarization. I can reduce this so that the time taken to process will be less. You see, right now it is showing 15 routes coming from external. So if I will do ASBR summarization, what is ASBR? The router where we redistribute from EIGRP to OSPF. So if I do redistribution, I can reduce this to maybe 2 instead of 15. Then the consumption of memory can be reduced. The size of the routing table will also get reduced. Right now it is 14,264. Now let me do and show you the summarization. Currently, if you check the OSPF database, type 5 LSA is very big. I'm going to summarize these 14 subnets. I'm going to summarize this. Where do I do that? I go to the ASBR itself, R7. And in R7, I'm going to say router OSPF 1. Summary address 172.16. No, not 172. 17.16. Isn't it? You see, 17.16. And I'm saying 255.255.00. Boom. I have summarized like this. As a result, if you go back now to router 1, please understand, earlier you had these many, you will not have now. This 14 will be shrinked to 1. Let me show you that. You see, it is shrinked to 1 in type 5 LSA. And if you check the size of the routing table, earlier it was 14,000 plus, now it is 11,000. Earlier here it was 4,000 something, now it is 2,000 something. Earlier here it was 26, now it is 13. Earlier it was around 15, now it is only 2. Not only here, even in the routing table, if you see, show IP route OSPF, you got only 1 instead of 15, so 14 subnets. Only 1. So summarization definitely saves the memory, saves the time taken to process. Your routing table is smaller, so time taken to process will also be less. Even the CEF table will be small. For 172.16, you don't have too many. Not 172.16, 17.16. You just got only 1 entry. So definitely time taken will be less. I can still ping 17.16.13.1 or 10.1. Even though I don't have a specific route, I got a summarized route. Show IP route, this one. I got a summary route. OSPF says if you want to go to this network, you need to go to router 2. How it knows that? Because I got a summary route. External type 1 summary route. You can also see this in CEF table. Show IP CEF 17.16.0.0. This is a CEF entry. It needs to go to router 2 via F00. So what you have seen is summarization on ASBR. What is the command that I used? I used the command summary address. But when I do summarization for ABR networks, means this area 1 network, I'm going to summarize this. Why, if you go and check in R6, the inter-area routes are too many. I want to summarize all this. Meaning, I want to reduce the size of the database, show IP OSPF database. I want to reduce the size of the type 3 LSA. And type 3 LSA is the LSA that is coming from ABR, which is here. R1 is the one who is the owner of these networks. Yeah. So if I want to summarize this network, where should I do? Not on R1, only on the summarization point R3. That is what called as ABR summarization. So I go to R3 and say router OSPF 1. You see this command, not summary address command. Here, area 50 range command. In area 50, if the network is coming with 172.16 range, you just, whatever the range is, you just summarize like this. That's simple it is. From area 50, don't advertise any specific network, just summarize like this and advertise. As a result, if you go now to R6, earlier you had all this thing in under type 3 LSA, but now under type 3 LSA you got only one summarized, and the routing table is also now smaller. Show IP route OSPF, not much big, small. Show IP route summary. Even this inter area is only 9. Earlier it would have been more than 20, or at least 20. So we have seen how LSA categorizes the advertisement that originates from various places. And we also saw in database, they are very nicely listed. And when we do summarization, ABR summarization, you saw type 3 getting reduced, inter area. When I do ASBR summarization, you saw type 5 was getting reduced, external LSA. What we are going to see in our next classes about stub types in OSPF. When we finish that, we are almost closing to the end of OSPF. After that, there will be some few small topics like authentication, so on. Any questions on what we have learned today?
No, that's all good. No, that's all good.
Okay. Koi, do you have any question? Fine. If